Welcome to my submission for the Fireflies lab in artificial life. So right now what we're looking at is the first example where they are all close enough to each other and can see each other with the coupling set to 0. And as you can see, they're struggling to get synced up. So next we're working with the same group of fireflies that can all see each other, but we changed the coupling value to 1. And as you can see, over time they start to sort of find sync with each other here, but it's definitely not perfect synchronization. And here's the same group with the coupling value to 2. As you can see, they're getting pretty synchronized here, so I guess 2 would be the tipping point maybe that we're looking for. I discussed the tipping point more a little later in the video, but 2 seems pretty good. So next I moved them further apart so that they really are only able to see their neighbors, and some of them I think can see like 3 and some of them can see 2. As you can see, this makes them struggle to synchronize. You see what you would expect, because the ones that are near each other are synchronizing with the ones near each other, but it's not reaching full synchronization, but it's getting closer. So next was the line. So as you can see, I started here with a coupling value of 2, and what I did was I started 2 here was not synchronizing them, so I started slowly increasing them during runtime. So here's just a time lapse of me increasing that up slowly until we get essentially a close to perfect synchronization, which was a pretty fun, satisfying process to do, actually. So I put it all the way up to 20, as you can see in there, just exactly blinking with each other. Next, I was just curious about how the coupling value would work if I started it super high, so I just started it at 10 to see if it would be able to figure out the perfect synchronization, and it could not. As you can see, that is too high of a coupling value. But here I went up to 3 to see, and that did not work. So when you do the thing, if it starts low and then you slowly increase it as they start to get close to synchronize, then you can get a perfect thing. But if you start the coupling value too high, then they could never really find a sort of balance in this group of about 10 fireflies. So going back to that original question, it seems like 2 is a pretty solid coupling value to start the project at. So next I got them back to that point of near perfect synchronization, so I could see what would happen if I pull one firefly away. I just thought if they were perfect like that, it would demonstrate it more clearly. So here it goes. And as you can see, it creates 2 separate groups which stay in sync within the group, but the 2 groups will not stay on the same synchronization, because they can't see each other, and so they've sort of formed their own cycles based on something like the average of their natural oscillation patterns, and then that one that's separated is just its own thing, obviously. So next we're doing the big ring of about 20 fireflies. So here you can see they are struggling to, this is obviously sped up, but they're struggling to get synchronized. That started at a coupling value of 2, and I just increased it to 4. And then when I pull this one away, you can see what happens to the oscillation pattern. I don't know how to describe this in words, but they're sort of without that link, breaking that link of the circle together, it's sort of each one is sort of falling behind in relation to its neighbor, sort of thing, if that makes sense. I decided I wasn't satisfied with that last run of the big thing because I feel like they weren't really properly in sync. So I redid that one with the coupling value of 6, and as you can see, they have this sort of thing where they are behind the neighbor, like I was describing before, and it seems like that is what is intended to happen for the purpose of this simulation. So let's try pulling this guy out again, and as you can see, the pattern does indeed stay together. Um, they're sort of lagging behind each person in this cool way, and the guy we pulled out is just going faster and is completely out of the loop here. So we're just going to Command Z to pull him back into the loop, and as you can see, he just jumped right back in to the pattern. So that is very cool.